All right, so next we're going to talk about the onto function or surjective function. Now, a function that maps elements in the domain X to elements in the codomain Y is called an onto function or surjective function if and only if every element in Y is mapped onto by at least one element of X. I'll say that again. So this is saying every element in Y. Remember, Y is your what? Codomain. So this is saying that a function is an onto function or surjective function if and only if every element of Y, every element in the codomain is mapped onto by at least one element of the domain X. Now, for a surjective function, for a surjective function, the range and the codomain are the same. Now, to determine whether a function f is onto, we can use a graphical method as follows. Sketch the graph of y is equal to f of x. Draw a line parallel to the x-axis, and if this line cuts the graph at least once, then the function is onto. All right. Now, that is important because remember, the same test is done to show that a function is injective. But in the case of the injective function, the line drawn parallel to the x-axis will cut the graph at most once. For it to be injective, it must cut it at most once. For it to be surjective, the horizontal line must cut the graph at least once. Now, at least means one time or more than one time. So it must cut it either one time, it must cut it at least once. So if there's a horizontal line that can be drawn that does not cut the graph, the function is not onto. It is not surjective. But if every horizontal line that can be drawn through the graph cuts the graph at most once, the relation is a function. All right, so let's have a look at example 12, where I ask which of the following functions are onto. Well, let's have a look at A. First of all, for A, if I draw a horizontal line below, parallel to the x-axis, below the x-axis, you will notice that it doesn't cut the graph at all. And for a graph to represent an onto function, every horizontal line that can be drawn must cut the graph at least once. Now, I have just drawn a graph that does not cut the graph of y is equal to x squared. Therefore, y is equal to x squared is not onto. All right, now for B, you can notice that every element in the codomain Y, is the image of at least one element in the domain X. Every element of the codomain Y is at least an image of at least one element in the domain X. Therefore, B is onto. And notice that for B, the range and the codomain are the same. For C, you'll notice that there are elements in the codomain B which are not images of elements in the domain A. D and E in the codomain B are not images of elements in the domain A. So therefore C is not onto. You'll also notice that for C, the codomain and the range is not the same. And for an onto function, the codomain and the range is the same. Elements in the range are A, B, C, and F. Elements in the codomain are A, B, C, D, E, and F. They are not the same. Therefore, C is not onto.